Hello, welcome to this video. In this video, let us see optimum condition for minimum power or maximum efficiency. We are talking about multi-stage compressor. Now, let us draw a PV diagram for a multi-stage compressor. So, we have PV diagram, pressure versus volume diagram. For a multi-stage compression, let us say this is our suction stroke. Okay, in the first compressor, that is low pressure compressor, then we'll have the delivery pressure of the first compressor, then the second compressor. All right, let us say we have intercooling. So, therefore, the first compression will be from here to here 1 to 2, then 2 to 3 is intercooling, and then 3 to 4, then 5, 6 and 7. So, this will be our PV diagram for a multi-stage compression. And we know that this is our pressure, that is initial pressure. This is our intermediate pressure Pi, okay, and this is our delivery pressure. We can call it as P3 or P4 here. Yeah, P4 is equal to P5 is equal to delivery pressure. Okay, this is our intermediate pressure, that is Pi is equal to P2 is equal to P6. Similarly, here this is our suction pressure, Ps is equal to P1 is equal to P7. Okay. Now, we are interested in deriving optimum condition for minimum power or minimum work, in other words we can say. So, let us start from the expression work is equal to, for two stage compression we have taken, later we will generalize. So, n by n minus 1 into P1 V1 to the multiplied by P2 by P1, that is first pressure ratio P2 by P1 whole power n minus 1 by n plus P3 by P2. I mean to say the second pressure, I mean this pressure. So, P4, let us call this as 3 otherwise. So, let us call this as 3. So, P3 by P2, okay, let us call this as 2 dash otherwise. So, P3 by P2 whole power n minus 1 by n minus 2. So, this is our expression for two stage compression work transfer. We are going to differentiate this work transfer with respect to P2 in order to get the minimum power or maximum efficiency. So, just to keep it simple, what I will try to do is replace this. So, let us assume, so that will help us greatly in derivation, differentiation. So, n minus, let us assume n minus 1 by n is equal to z. Okay. Now, let us rewrite it, n by n minus 1, I will keep it as it is. So, P1 V1, now this can be P2 by P1 whole power z. So, while differentiating, that will be helpful. So, this will be P3 by P2 whole power z minus 2. Okay. Now, in order to get minimum work or power, or we can say maximum efficiency, we have to differentiate, call this as equation 1 if you want to, equation 1, and we must equate it to 0. I mean, we must differentiate it with respect to intermediate pressure, or what we call it as P2. Okay. So, let us differentiate the expression 1 in a, that is dW divided by dP2 must be equal to 0. Now, I will differentiate it. So, n by n minus 1 P1 V1. So, before I think differentiating, I will write this dP2. Before differentiating, let me try to keep the expression simple. So, this must be equal to 0, that is what we are trying to do. We have not differentiated it. I am just bringing this P2 power Z, let this be on the numerator. P1 also I will bring it to the numerator, that will be P1 power minus Z, okay, plus this P3 power Z is there only, and this P2 if it comes to the numerator will become minus Z, and this minus 2 is there only, okay. Now, let us differentiate now. Now, this must be equal to 0, n by n minus 1 P1 V1, and we know that P2 power Z, we are differentiating with respect to P2. So, we know that differentiation of x power n is equal to n x power n minus 1, okay. Now, we are talking about P2 power Z. So, we will have Z P2 power Z minus 1, okay. Now, P1 will remain as it is, and this is our first term, and let us go to the second term. Second term P3 power Z will remain as it is, and n, that is power, will come here minus Z P2 power minus Z minus 1, and this term is our second term, okay. This is our second term, and this will become 0, minus 2 will become 0. Now, we can further simplify this n by n minus 1, I will keep it as it is, and let us say this is Z P2 power Z minus 1 P1 power minus Z plus, now let us multiply this minus sign here. So, this will be minus Z P3 power Z P2 power minus Z minus 1, and this must be equal to 0. And we know that this cannot be equal to 0, that is we know that n by n minus 1 and P1 V1 cannot be equal to 0. So, what we can further write it as, so this only this term must be equal to 0, that is Z P2 power Z minus 1 P1 power minus Z minus Z P3 power Z P2 power minus Z minus 1. Only this must be equal to 0, because we know that this cannot be equal to 0. So, let us send this term other side, like Z P3 power Z P2 power minus Z minus 1 must be equal to Z P2 power Z minus 1 P1 power minus Z. Now, this Z cancels out. What will remain with is, I will try to send P2 to the one side. So, P3 I will keep it here, P3 power Z, P1 will come here as minus Z, P1 power minus Z. So, P2 power Z minus 1 will be here, and P2 power, this will go to the denominator minus Z minus 1. So, this P2 power minus Z minus 1, P2 power minus Z minus 1. Now, let us solve it. So, P2 power Z minus 1 in the numerator, P2 power, this if it comes to the top, it will be plus Z plus 1, okay. Similarly, on this side P3 power Z, let this be P1 power Z. So, that will be positive when it comes to the numerator. Now, we will have P2, let us add the power. So, Z minus 1 plus Z plus 1. So, this minus 1 plus 1 goes off and we will have P2 power 2 times of Z, P2 power 2 times of Z, and this side we have P3 P1 whole power Z, and this power we know this will cancels out. Okay. So, what we have now is the intermediate pressure P2 is equal to, P2 square is equal to P3 and P1, or we can say P2 is equal to square root of P1 P3. So, in order to get the maximum efficiency or minimum power supplied to the compressor, the intermediate pressure Pi, must be equal to square root of initial pressure and delivery pressure. That is what we mean by this expression. Now, let us try to generalize this expression. Now, what do we mean by generalize this expression? Generalizing this expression. So, now we can say that pressure ratio, let us call it as P2 by P1 is equal to X. Similarly, the pressure ratio P3 by P2 is equal to X and P4 by 3 and so on. Okay. Now, we can write like P2 is equal to X times of P1. Okay. So, from first expression P2 is equal to X times of P1. Similarly, the second part P3 by P2 is equal to X. Now, P3 can be written as P2 times of X. Now, P2 we have got an expression from equation, let us call this as equation 2. So, from equation 2, so P3 is equal to P2 is what? X times of P1 and this X is there. So, therefore, it will be X square P1. Okay. So, P3 is equal to X square P1. Similarly, P4 is equal to X cube times of P1. Now, what did we get? We get pressure n plus 1 will be equal to x power n times of P1. So, if you want pressure at any given point or pressure of a particular stage, we can get like in terms of number of stages. Let us say if number of stages are 2, we can write like this will be x power 2 times of P1. So, we have written a pressure in terms of initial pressure and pressure ratio. Okay. Now, similarly, let us derive. Now, let us go back to the expression work transfer. Now, we have started this derivation with the same concept. We are interested in work transfer. Now, what is our work transfer is given by n by n minus 1 P1 V1 multiplied by P2 by P1 whole power n minus 1 by n plus P3 by P2 whole power n minus 1 by n minus 2. So, this was our expression. Now, for we are of course deriving work transfer for minimum work or maximum efficiency. So, for minimum work or minimum power input for minimum work, we have derived that intermediate pressure square or intermediate pressure is equal to square root of let us assume that 2 stages. So, P1 P3, or we can also write it like Pi square is equal to P1 P3, or we can say that Pi into Pi is what? P2, correct. So, P1 P3. Now, we know that Pi is equal to P2. So, in our expression Pi is equal to P2. Now, I will write P2 into P2 is equal to P1 P3, or we can say P2 by P1 is equal to P3 by P2. This is what we wanted to prove from this expression. So, the pressure ratio between first stage and pressure ratio between second stage are same, that is what we mean. Okay. So, therefore, we can again write, I will come back to this expression now. So, I will come back to the expression now. So, we were writing this n by n minus 1 P1 V1. Now, we are saying that this P2 by P1, and this also we can write it like P3 by P2 is equal to P2 by P1. So, this also can be written as same. Okay. Now, therefore, we can say that n by n minus 1 P1 V1, this can be written as 2 times of pressure ratio between first and second, P2 by P1 whole power n minus 1 by n, this minus 2 will be there. Now, we can take 2 common out here. So, 2 n by n minus 1 P1 V1, now this is P2 by P1 whole power n minus 1 by n minus 1. So, this will be our minimum work for 2 stage. Now, we can generalize this expression as usual. We can generalize this expression, that is, now work done, general expression. Now, where n is equal to number of stages, Now, we have got this expression for 2 stages. So, this will be n. For number of stages, if it is 3, this will come out to be 3. So, n by n minus 1. So, P1 V1. Now, this pressure ratio can be written as Rp if we want. This will be n minus 1 by n, and this will be minus 1. Okay. So, this is our general expression for minimum work transfer. Now, let us call this as equation 3. Now, equation 3 can be further simplified. Now, equation 3 can be further simplified in terms of delivery and suction pressure. Remember, the pressure there is intermediate pressure P2. So, therefore, this can be further simplified in terms of delivery and suction pressure. Now, how do we write that? Now, P2 is square root of P1 and P3, correct. So, this can be written as P1 power half and P3 power half. So, we are basically trying to write pressure in terms of delivery or suction pressure. We want to eliminate P2. So, now let us write this equation 3 again. So, therefore, work transfer can be written as 2n by n minus 1. This is okay, P1 V1. Now, this can be further written as P2 can be written as P1 power half, P3 power half whole power n minus 1 by n minus 1 divided by this P1 power n minus 1 by n is there only. Okay. Now, let us simplify it. Now, work transfer is equal to 2n by n minus 1. So, P1 V1. Now, P1 power n minus 1 by n, that is 2 is multiplied now. P1 I mean half is multiplied with the power. So, that will be 2. Then again this will be P3 power n minus 1 by 2n minus 1, and this is there P1 power n minus 1 by n. Now, let us simplify it, like we will take P1 to the numerator so that we can simplify it. This will be 2n by n minus 1 P1 V1, and this will be P1 power n minus 1 by n. I will take this to the numerator. So, P1 power 1 minus n. So, that will be minus n minus 1, that will be nothing but 1 minus n divided by n. Sorry, this is 2n, correct. So, the next term is taken to the numerator P1 1 minus n by n and multiplied by P3 power n minus 1 by 2n minus 1. So, this will be our expression. Let us simplify it further. N minus 1 P1 V1. So, P1 over n minus 1 by 2n multiplied by, now what we can do is that we will multiply and divide this term by 2, so that we can add the powers. So, this does not change the meaning, we are multiplying and dividing the power by 2. So, multiplied by P3 power n minus 1 by 2n minus 1. So, now we can add the powers, because now we can add the power. So, P1 V1, P1 power 2n is in the denominator, in the numerator n minus 1 plus 2, I will multiply 2 into 1 2 minus 2n into P3 power n minus 1 by 2n minus 1. Okay. Now, let us add the power. So, 2n by n minus 1 P1 V1. Now, what we will get? P1 power, this 2 minus 1 is 1, 2 minus 1 is 1 and minus 2n plus n. So, minus n. I will see minus 2n plus n minus n plus 2 minus 1 is plus 1 divided by 2n into P3 power n minus 1 by 2n minus 1. Now, we have got 2n by n minus 1 P1 V1. Now, this can be, I will take this P1 minus common. So, I can write it like n minus 1 by 2n. So, multiplied by P3 power n minus 1 by 2n minus 1. Now, 2n by n minus 1 P1 V1. So, now what we can do? We can send this to the denominator. So, P3 power n minus 1 by 2n. So, since it is negative sign, P1 power n minus 1 by 2n. So, when it goes to the denominator, it will be positive minus 1. So, we have written now the same expression in terms of delivery pressure and suction pressure, that is what we wanted. So, P3 by P1 whole power n minus 1 by 2 times of n minus 1. So, this is work in terms of delivery and suction pressure, Now, we can generalize as usual, generalize where n is equal to number of stages. Okay. So, n is the number of stages. For 2 stages we had got 2. So, n into n divided by n minus 1 P1 V1, and this pressure ratio is delivery pressure divided by initial pressure divided by n minus 1 divided by n small n, that is 2 n for 2 stage. For 3 stages it will be 3. So, minus 1. So, the expression which we have got is the minimum work required for number of stages in terms of delivery and suction pressure. Thank you.